Okay, so let's find some values between us and the Earth. So to find A, the force of gravity, we're just going to use our G(m)(m) over r squared. Now, what do we use for our r? So you need the total radius. So you need from here to here. So that would be kind of our r total. So you have to add in the radius of the Earth plus the radius above, or the distance above. Okay, so I would encourage you just to kind of do this on the side, because you're using this number in this problem 3 different times, actually 4 different times. So it's useful if you just kind of have that number on the side. So 638 times 10 to the 6 plus 500 kilometers. You do have to convert that. So a lot of people, a big mistake is just to go plus 500. It's plus 500,000, right? 500 kilometers. So you're going to add plus 500,000. That's going to give us 6.88 times 10 to the 6. Okay, so when we go for FG, we're going to do big G times the mass of the satellite times the mass of the Earth divided by, now we're going to use this total distance, we're going to square it out. Okay, so make sure you're able to do this. $67.41. Okay, letter B. There's a couple ways to do this. Kind of the generic way to find little g is just doing what I derived for you earlier. That is, little g is equal to big G times the mass over r squared. How should little g compare to 9.8 here? Should be greater than, equal, or the same as 9.8? Should be less, yeah, should be less. 667, 10 to the negative 11th. Which mass is this? The Earth. 598, 10 to the 24th. Divided by r squared. 638, 10 to the, nope, that's wrong. I'm glad I did that so you can see what a lot of people do wrong. What should I be doing? Not 638. 688. 10 to the 6. I'm getting 8.4. 8.43. Okay, just as we suspected, it did decrease. Yeah.
Because we already found FG, can we just say FG is equal to mg and just solve for g?
Yes. So you could take the answer that you previously got, divide by the mass of the satellite, and you should come up with the same answer. Yes. Okay. How do we find letter C? Bless you. Yeah, we'll just use UG. So we're just going to go big G, M over R. So it's almost the same, right? Except there's the R squared versus the R, the slight difference. That's because, remember, we multiply by h, which is the height above the center of the Earth. I'm getting about 4.3 times 10 to the 10th. Four point three 10 to the 10th. Again, make sure you're able to calculate these out, plug them in. Okay, chemistry review. How do we find density? Mass over volume. Okay, geometry review. How do we find the volume of a sphere?
4/3 pi r cubed.
Okay, now what do we use for the r here? Do we use our r total? We use the r of the Earth. R of the Earth, yeah. So that's just the r of the Earth here. Someone got the answer? You need me to do it. Okay, so what do we got? The mass of the Earth, 5.98 divided by 4/3 times pi times, what was our radius? 0.38 e to the 6. We need that Q button, don't we?
Carrot and then
5,500. Is that what you guys are getting?